Hi guys, I'm Milad and welcome back to another tutorial about a smart remesh. And now a smart remesh number two. A smart remesh number two with a lot of things to do and a lot of features. But first of all, I would like to thank you for the amazing response to a smart remesh number one. Really, it was amazing, and thank you for trusting me. Really, really, I appreciate it about you about trusting me. But now, uh, let's go. Before I start, I just want to mention something that was an issue in the previous version. Previously, when you clicked remesh hard surface, if your viewport was in material preview, like matcap or any other shading mod, it would automatically switch to solid shading and enable the wireframe display. I've fixed that in this new free version. And now, whatever viewport shading mode and setting you are using will be preserved. So, whatever you are in material preview, using a matcap or using any other viewport setup, a smart remesh will keep those settings exactly as they are. It also no longer automatically enable wireframe mode. So both of those issues have been fixed in this version. Okay, in a smart remesh number two, there are three new sections. Section Smart Cleanup, UV, and Erase Useless Loop. And all right, let's start with the smart cleanup section. I will explain what parameter it has and how you can work with them. I'm going to select a part of the model and use that area as an example. Inside a smart cleanup, we have a very important option called stay inside lines. This option basically lets you control where the loop cut density reduction happens, either inside your line selection or outside of your line selection. For example, look at this. When I select a loop edge here and decrease the value of remove, we can see remove our edge loop. Okay, and we can control it. But when we uncheck stay inside line, look at this. All loop edge removed across your model. Look at here, remove across your model. Sometimes we need to control it and remove it, our loop edge across our model. Sometimes we need to remove it only inside of our line. Good. Then, what I explained earlier was how the cleanup work based on a single selected line. Basically, how the effect is applied and how the edge loops are removed. But now, what happens if we have two selected lines? For example, I selected one line. Sorry, I selected one line here, and then I will select the second one. Okay, sorry. Both of them. Now, take a look. What happened here? very important things. When you finish the process, finish the process or remove your edge loop, press confirm. If you don't press confirm, after that, everything affected on previous model. What does it mean? Here, I selected, for example, this one, and I selected this one. And when I decrease number, you can see everything happen here, not here. Why? Because we didn't confirm. So I confirm this one. Now everything is ready for next process. So continue our tutorial about here and select here, and we can decrease value and see what happened on our edge. So it automatically understands that the edge loop inside the area between these two lines are the ones that should be removed. That's it. Let's move on to another feature: erase useless loop. Erase useless loop work in several different scenarios, so you can use it on different type of geometry. I will show you a few examples so you can get a better idea if get the better idea if how it works on different form and situation. Let me select another model here, and as an example, I want to select this one. Okay. Before I start, I want to remove it. Back it. Okay. Before I start, I want to show you, I want to tell you what we mean by useless edge loop or simply useless loops. There are loops that, if removed from the model, have a little to no noticeable effect on its overall shape. So, since they don't contribute much to the form of the model, we can safely remove them. So, pay attention to what happened here. I increase the value and more loop remove. After a certain point, the loop begin remove start to affect the the actual shape of the model. Look at this. So we can see remove edge loop on our model. But here, when you increase more than usual, our model affected. So here we need a way to define which areas can be affected and which areas should stay protected. In other words, we need to tell the tool which edge it should keep, which edge it should keep and not remove during the cleanup process. You can preserve it. For example, for this one, I select mark shape. For example, I want to select or define short key for this one, short key C and short key Control C. And here, I selected this one. Look at this. I want to select this edge, C, mark sharp, this edge, C, and I think this edge is okay, is good. And look at this. When we increase the sharp, no. Aha, I forgot it. Confirm it. Okay. Confirm this one and this one. And look at here. When we increase the value, everything remove instead of these lines, this edge, and keep it this edge, and keep your form and your shape very easily. So when you select or when you mark some edges on your model, it means you want to keep your model and you want to keep the edge with this method. Good. So here I want to show you another example. This one. Here, another example, this model was generated with the Tribe AI, and I exported it using the quad topology option. And now I have it here, and I want to show you how we can reduce the topology on this kind of model. Mm, this one has a mostly rounded shape and with the circular form, especially quad-based model generated by AI tools like Tripod. You will often get a lot of edges that form clean, continuous edge loops. That means many of these loops can be removed relatively and easily. But the important question is how can we remove them in a smart way while still preserving the original shape of the model? We can remove our loop edge based on axis. For example, I want here, I want to select this one, convert this. Okay, now uh, increase the value. Look at this. I want to put a number about here, and we can see decrease the edge, the loop edge, in several axes, x, y, and z. Now I want to limit it only on x axis. For example, x1, it's mean limited and remove only edge on x axis. And we can increase the number like this one. Good. After that, in second step, I want to decrease another loop edge based on z-axis. So before that, confirm your process, select z, and here we need to change to 0. Now increase remove pair kept, for example, 2, 3, 5, example 5. Look at this, very easily our model remesh it. Let's move on this car. I want to show you how we can remesh it to reduce the mesh density while also preserving its material. In Smart Remesh number 1, I already explained that you should apply all the chains on your model and make sure all the modifiers are applied before starting the remeshing process. So I won't go through all of throughout all of that gain here. At this point, you already know that any change coming from modifiers should be applied before you start remeshing. Good. Here we have two parameters we are going to use a lot: Coplanar and remove straight loops. These are probably the two parameters you will work with the most. Remove straight loops is pretty self-explanatory. As you increase the value, remove more straight edge loops from mesh. For example, here I want to work on this one and keep the material mod, remesh on flat panel. like this is good. Oh, look at this. When we increase the number, remove a lot of straight loop. But the higher number is not good. We can keep it in here. It's good. And Coplanar, on the other hand, control how much two neighboring faces are allowed to differ in angle will still being treated. Okay, Coplanar, on the other hand, control how much two neighboring faces are allowed to differ in angle while still being treated as a part of the same flat surface. For example, when we increase the number, we can see we can see the effect and what happened. As you probably noticed, throughout the entire remeshing process, the material didn't change at all. It was preserved and stay exactly where it was on the model, our model. All right, let's move on to our next model, which is a receiver. This time, we want to remesh the receiver while preserving its exciting UVs. And so the UV mapping stays intact and doesn't change during the process. How do we do that? All right, let's move on to our next model, which is a receiver. This time we want to remesh the receiver while preserving its exciting UVs. So the UV mapping stay intact and doesn't change during the process. So how do we do that? Look at this. Here we have some details. Good. Now remesh hard surface and we lost the details, but our UV keeps. Look at this. We remesh it, but the UV preserved. But here, look at this. We have some problem on UV here, or maybe, okay, here we have a problem. Decrease the number. Okay, fix. And we have some issue here and here on our UV. No problem. So now we need two things, detail and fix this issue. For this step, we need to bake from original. It's mean you can put it on, you can select your resolution, for example, 2K, and all maps check on and bake from original. Look at this. After maybe 10 or 20 seconds, depend on your model, our texture baked all of them. Height, metalness, roughness, base color, normal bump, everything will be baked. We are waiting for baking now. Tada! Everything baked very well. We can see detail here, our detail here, our detail very well here, and it's very good. Amazing, yes? Good. Okay, there are three more parameters I want to explain. The first one is show UV seams. As you know, make sure you are in edit mode when you enable this option. Once it's enabled, it simply displays the exciting UV seams directly on the model. And now, oops, turn on edit mode, and we can see we can see the exciting UV seams on our project. Okay, good. The next option is seams to sharp. This this option converts those UV seams into sharp edges. And if you remember from earlier, sharp edges can be used to define boundaries from the remeshing process. When an edge is marked as sharp, it acts as a boundary and helps prevent the remeshing process from affecting the geometry across the area. Okay, there is one more option I want to show you as well. Only back to a start button, uh, which I forgot to mention earlier. Back to a start, take the drop useless process back to the state before the useless loops were removed. So basically, it works like a reset, but only for a drop useless section. Finally, thank you for watching all the way to the end. I hope you enjoy the new features and find them useful in your workflow. You can um, connect me through Discord and using the link below here. And feel free to reach out if you have any questions. Bye bye.